Okay, hope you are wrapping up all of your factoring for chapter 10 on the worksheet that's due today. Chapter 11 is going to require a lot of those factoring skills. We're going to start out with lesson 1, which isn't too horrible as the early part of the chapter, but it's going to get complicated as we go. So 11.1 is going back to your work with ratios and proportions. So remember that a ratio is just a comparison of one thing to another. So in class I talked quite a bit about like number of girls to number of boys. It's not a fraction because it's a part to part, not a part to whole. Okay, so I'm just making this up. Let's say we have 17 girls in class and we have 21 boys. That is a ratio, 17 to 21. You can write it so that it looks similar to a fraction. Okay, so this is a ratio. You see that word. A proportion is when you have two equal ratios. So an equation, let's say I said equals okay, that ratio, 34 over 42, those ratios are equivalent. If I put them together and I say they are equal to one another, this whole thing is called a proportion. So, such as here, it's telling you that an equation that states that two ratios are equal, that's the definition of proportion. This ratio is equal to this ratio, the whole thing is a proportion. So, that's a little bit of vocabulary there. It says this proportion is read as A is to B. A is to B like C is to D, or as C is to D. When the ratios are written in this order, the numbers A and D are called extremes of the proportion, and the numbers in the B and C position are called the means of the proportion. Okay, extremes and means. You won't need that a whole lot necessarily in this chapter or this section, but if those words are mentioned, refer back to your notes, and that's what they mean. Okay, we have a couple properties in here. One is the reciprocal property, and this one, well, you know what a reciprocal is, right? So if you take a fraction, 2/3, the reciprocal is 3 over 2. It's just turning it upside down. And I think this just makes 100% sense. I don't know, if they're telling you that A over B equals C over D, they're saying if you flip the A over B upside down, it will equal the other fraction's reciprocal as well. Here it is with numbers. Okay, so if you say that 2/3 equals 4/6, which it does, then its reciprocal, 3 over 2, will equal the other ratio's reciprocal, 6 over 4. Okay, so just know that if you have to flip both fractions or ratios upside down in order to say that the reciprocal property works. Alrighty, cross product property. This we're going to be using a ton. Incorrect use of the word, but okay, cross product property. It's fascinating. The product of the means equals the product of the extremes. That's how they say it in the definition. It simply means this. If you multiply the numbers in these two, or variables in these two positions, so A times D will equal the numbers in these two positions, so B times C. Okay, the product of A and D equals the product of B and C. Here's an example to prove it to you with the 2/3 and the 4/6 example that I had up there. Okay, you are using this with proportions when you have something compared to something, an equal sign, and something compared to something. So you can say 2 times 6, put an equal sign in between. Oh, sorry, down here. 2 times 6, an equal sign, and 3 times 4. Again, if I circle it, it might help you. The product of this, 2 times 6, equals 3 times 4. They both equal 12, right? All right. When a proportion involves a single variable, finding the value of that variable is called solving the proportion. So if the directions say solve the proportion, you are trying to find the value of the letter. So here we go. Example 1, solve the proportion. What is the value of that letter? Please don't guess and check. Try to learn these new properties. Use these new properties to solve for the letter. Show your work. So I'm going to say 2 times W equals 3 times 3. And then I'm just going to solve for the W. 2 times W equals 3 times 3 is 9. Divide both sides by 2. And W equals 4.5, 4.5, however you want to write it. You could leave it 9/2. Okay. They're going to get a little tougher as we keep going, but that's the process that you're going to use. So you're going to multiply 10 times 5 and set it equal to t times 2t. So the letter T times 2t. 10 times 5 is 50, equal sign. 2t times another t is 2t squared. If I remember you want to get the t by itself. So if I divide both sides by 2, 25 equals t squared. Question being, what number times itself equals 25? To get rid of the 2 or the exponent, you are going to take the square root of t squared and the square root of 25. Show it on both sides. T equals, remember plus or minus 5? We haven't done that in a little while. But what number times itself makes 25? Negative 5 times negative 5 equals 25. And a positive 5 times positive 5 equals 25. So both of those answers, t equals 5 or negative 5. 2 solutions there. 2 x-intercepts, still doing the same thing. Carrying on with chapter 11. All right, so I'm going to pause there. You can stop the video if you want to go back and look at any of that. All right, second page. I uploaded these for you. I don't know, because you don't have printed copies, what the best way for me to do this is. So hopefully that helps. I'm not sure. If you have any suggestions, I am willing to listen because I have never done this before. Okay, we're going to continue example 3 exactly like we did example 2, where we multiply the negative 3 times 2d. I'm going to show that as negative 3 times 2d in parentheses. I'm just writing out all my work. Equal sign. And then the d times the d minus 3. So d times d minus 3. And then I want to multiply all of that out. So a negative 3 times 2d gives me negative 6d. And d times d minus 3 is the distributive property. So I will get d squared minus 3d. All right, this is where last chapter comes into play. We are going to put everything on one side so that 0 is on one side of the equal sign and everything else is on the other side. So I'm going to add 6d, like terms, so I'm adding it right here. This side now equals 0, and I get d squared plus 3d equals 0. Remember that 0 is in the place of the y. You're still finding x-intercepts. So I am going to factor in order to solve. Factor to solve. Just like you did on those last worksheets. So both terms, the d squared and the 3d, have a d, or a common factor of d, that I can take out, and I'll have d plus 3 equals 0. So think about what your solutions could be. In order for this factor here to equal 0, d plus 3 equals 0. So d would be a negative 3. Right? Negative 3 plus 3 equals 0. That's one of my solutions. Or if I'm just solving this algebraically and not really thinking much about the problem, I would say, and d also equals 0. Okay, here's the thing about ratios and fractions, right? So if I have d equal to 0, that means my denominators over here are going to be 0. And you can't have denominators be 0. So 0 cannot be my solution. It's called an extraneous solution. You need to check when you're finished with your problem and you have 2, 3 solutions, however many solutions you have. Go back and put them back into the problem and make sure you do not get 0 as a result in your denominator. Okay, if you do, cross that solution off. It's not one of your solutions. Okay, so in example 3, my one and only solution is going to be negative 3. Email me any questions you might have. All right, example 4, word problem. The route for your town's 4th of July parade stretches 2 miles, which is 10,560 feet. So a distance for the route. Spectators, people watching, are usually evenly distributed along both sides of the route. On one side of a 50-foot section, you count 15 children. Estimate the number of children who attend the parade. All right, so think about how could you compare something compared to something else equals something compared to something else. You have spectators or children and length of a section of road, I guess. All right, so in that 50-foot section, we have 15 kids on one side. So I'm going to say 15 children along a 50-foot section, right? The total length of the parade, okay, so like this is length of road. Total length of road, 10,560 feet. And number of children, we don't know. So I want to point something out. I'm going to adjust this a little bit, but total children, total length of parade or road, right? This is a section. We've done similar things to this before. But if I have kids on top and road on bottom, on the other side I have to have kids on top, road on bottom. I could have started this problem as length of section on top and children on the bottom, but then on the other side I would have had to have the road length on the top and the number of children on the bottom. Okay, so setup does matter. Children to road, children to road. Kind of like a sample and out of the total. And like I said, we've done this with DNR things, and I know a number of fish in a lake prior to this. This is similar. However, the 15 children in this problem, if you read it really carefully, these 15 children are only on one side of the road. So, you know, like, I'm just going to draw a road over here. Kids. These are kids. They're only on one side. And when you go back and read the problem, it says that spectators are evenly distributed on both sides of the route. Oh, so if there's 15 over here, there's 15 over here also, or there's 2 sides of the road. So you have to multiply that top times 2. Now, not every problem will be that way. You just have to read all your words carefully. So I'm going to keep this problem going then. So 2 times 15 is 30. I'm going to rewrite it. 30 over 50 equals x over 10,560. I am going to multiply the 30 times the 10,560. I'm going to write it out. 30 times 10,560 equals 50 times x. Okay, I'm not finished with this problem yet, but I just kind of want to highlight that so that you're not seeing it along with the words that are up there. Okay, so one more time, I did 30 times 10,560 equals sign 50 times x. We'll do a little math there. The 30 times the 10,560. Yeah, no, I don't have a calculator with me. Just a second. See if you can do it faster than me. 30 times 10,560. 316,800 equals 50 times x. What are you going to do on both sides to solve for x? We'll just divide that by 50. Is 6,336. Children. 2 miles. That's a lot of kids. That would not be a parade in La Crosse, but there you have it. Estimate number of children that attended the parade. Oops, sorry. There we go. 6,336. And I'll leave that there. Take a picture or whatever you want. All right, last problem, example 5. Scale drawings. This is used quite a bit for scale drawings. Okay, so you want to make a scale drawing of a parade float. The float is 5.5 feet high and 10 feet long. All right, so you have height and you have length. So we're going to say height compared to length. 5.5 over 10. Equals. So that is the actual float. Your model is going to be 14 inches long. Since this top unit is feet and this bottom unit is feet and they are the same unit as each other, you do not need to change this into feet or these two into inches. Okay, but if the top and bottom were different units, that's where it comes into play. Okay, so we're just going to say the height is x. How tall should your model be? Unsure. That's what we're going to find out. Okay, so we're going to take the diagonals multiplied by each other. 5.5 times 14 equals sign 10 times x. I can do this one in my head. This is 5.5 14s. So 5 14s, let's see, 5 14s, 50 and 20 is 70. And then half of a 14 is 7. So 70 and 7 is 77. That was me doing mental math out loud. You can use a calculator if you need to. All right, if I divide both sides by 10 to solve for x, I get 7.7. And then keep in mind that it's asking me how tall this should be, and this is my model, and my model is in inches. So my model should be 7.7 inches high. Okay, I will put which problems you should try in your book on Google Classroom. Please try them all. Please check your answers in the back of the book. Don't be lazy. It's just going to come back and bite you in the butt. So, yeah, see you online. Ask me some questions. Videotape yourself. Send me a happy message if you want. I miss you guys. Bye.